Okay, let's talk about the last part of this long section. We're looking for the equations of perpendicular lines. Perpendicular lines. Okay, so recall that in the last video we studied two lines are parallel. If either they are both orthogonal, vertical, they are both vertical. This is one special case. Or they have the same slope. Okay, they have the same slope. So two lines are parallel. There are two situations. One situation, they're both vertical, then they are parallel, because in this case, there's no slope. If they have slope, they will have the same slope. So that's an important observation for the last part. And in this part 10, we are looking for the perpendicular lines. What lines are perpendicular? They intersect the corner, the angle is 90 degrees. And so this is a perpendicular, right? They form the right angle at the intersection part. Okay, so we are not going to give the detailed proof about the criterion for perpendicular lines. We just list them. So it's called a theorem. It requires a little bit of computation. Criterion for perpendicular lines. Two non-vertical. Two lines are both non-vertical. Okay, in this case, both lines have the have slopes. Two non-vertical lines are perpendicular. If and only if the product of their slopes, so you have two slopes, is the product is equal to -1. The product is equal to -1. Very important. You have the product of two slopes equal to -1. You can claim two lines are perpendicular. Okay? All right. So this is a criterion. Another special case after we get this, another case is that one line is horizontal, the other line is vertical, and naturally they are perpendicular. And in this case, one is vertical. So it is not in the discussion of this criterion. But this one is trivially obvious, right? It's obvious. So let's see the application. Example. First, if we know that one line has the slope 3/2, then any line with slope -2/3. Check here, -2/3, because the property between the -2/3 and the 3/2 is that their product is -1. Then any line with slope -2/3 is perpendicular to the first line. Okay, so You just check if the product of them is equal to -1 or not. In other words, if here is m, the slope is m, then this one will be -1 over m. Okay, so one slope is m, the other one will have slope -m. And of course, this m is not equal to 0, because if m is 0, you get a horizontal line. Then the corresponding vertical line, a corresponding perpendicular line will be vertical. Then we're talking about the non-vertical lines, so we don't care that case. Only for two non-vertical lines, the slope equal to 0 will imply the other line is vertical. Then we don't care if the product is negative or not. Okay, so one has slope m, the other one must have slope -1 over m in order to guarantee two lines are perpendicular. Let's see a concrete example. Find an equation of the line that contains the point 1, -2 and is perpendicular to the line x plus 3y equal to 6. Graph two lines. All right, let's try to solve it. First of all, we are looking for the equation of a line containing a point. So if we can find the slope of this required line, then we will have a point slope form. But the slope is not directly given. The problem gives us a property. This line is perpendicular to the second line, x plus 3y equal to 6. Okay, so perpendicular means the product of the required line, the product of the slope of the required line times the product of the given line is equal to -1. So we're looking for this, the slope of this line. So we start from x plus 3y equal to 6. We move x to the right side and divide it by 3. So it has slope -1/3. This line has slope -1/3. Then the required line must have slope +3. How do I get a +3? I try +3 is equal to negative. You see, when you get m, this is m. Then you will get a -1 over m, -1 over m. Negative sign cancelled. 1 over m is a 3. But in fact, you just look for you flip it and add a negative sign. You flip it 1 over 3, you get a 3, and add a negative sign, you cancel negative sign. Okay? One slope is P over Q. The other slope will be Q over P. You flip the numerator and denominator, and then with a negative sign. Add the negative sign. Okay? So you flip 1 and 3, add a negative sign. That a second negative sign cancelled with the first negative sign. You get a 3. Okay, so the required line has slope 3 containing the point 1, -2. The point slope form is what? Is y minus y coordinate is equal to slope times x minus x coordinate. So this is our equation. This is a required equation. All right, it's very clear. Now let's try to sketch them. Let's try to sketch them. For this one, let's try to find x-intercept and y-intercept. When x is 0, y is 2, okay? So for x plus 3y equal to 6, x is 0, y is 2. X equal to 0, you get 3y equal to 6, y is 2. 1, 2, this is 2. This is y-intercept. And when y is 0, x is 6. This is x-intercept. 2, 3, 4, 5, 6. And then you use there's a line to connect them. So this is the first given line. This is first given line. And now let's talk about this the required line. The required line passes through 1 and negative 2. 1 and negative 2. 1, 2. 1, negative 2. This point. The slope is 3. This one, slope is 3. 3 is rise over run. So it's a 3 over 1. Rise is 3. Run is 1. Okay, rise is 3, run is 1. So it's positive, so you move to the right. Run is 1, right 3, 1, 2, 1, 2, and 3. Right, so you have a point here. Well, let me see, 1. So this is negative 2. Negative 1 and 0 and 1. So this is a 2, 1, 2, 1, 2, 1. Let me see. No, 2, 1 is not there. Okay, 2, 1 is here. This point is 2, 1. So we just connect them. Well, you see, if my scales are proper, they should look like orthogonal, perpendicular. Perpendicular has another word, orthogonal. They mean the same thing. Orthogonal, you have 90 degree. Perpendicular, you also have 90 degree. So these are the two lines. Okay, so rise over run. Rise, you have 3, you lift 3 units. So from here you get 1, 2, 3. 3 units, you get 1. Run is 1, so from 1 to 2, you get 1. So it's a 2, 1. This point is 2, 1. Okay, it's a rise over. Okay, so this is the example of looking for the perpendicular line. Another one, let's try to solve this. I always try to give you 2 methods to solve perpendicular question. When this equation, when the line is given by the general equation, x plus 3. X plus 3y equal to 6. Then the corresponding has corresponding perpendicular lines like this. So you first switch the coefficients. So the coefficients must contain the sign, okay? So here it's a positive 3. You move positive 3 to x. X has a positive 1 as coefficient, so it's a positive 1y equal to d, whatever constant we don't know. And then it's a positive 1, but we're going to change the sign to be the opposite. If it's a positive, we change it to be negative. Okay, so you switch the coefficient of x and y. Then change one sign to be the opposite one, to be the opposite. If it's positive, you change it to be the negative. If it's negative, you change it to be positive. Just change one. Don't change both. Just change one. And put D. Put a letter. Put D on the right-hand side, on the right side. Well, D, of course, is unknown. We don't know what D is. But this line will guarantee, this equation will guarantee the corresponding line is perpendicular to the first line. Why? Because you try that. If you move this 3x to the right-hand side and divide by -1, you see the slope is 3. So remember here, we require the slope to be 3. Okay? Okay, so this is a verification why this works. And then, how do you determine D? It contains 1, -2, 1, -2. So 1x is a 3. 1x is a 1, so it's a 3 minus y is -2 is equal to D. So D is equal to 5. So the equation becomes, the equation is 3x minus y equal to 5. Well, let's see if it is equal to this one. So it's a y minus -2 is a y plus 2 is equal to 3x minus 3. You move 2 to the right side. Y is equal to 3x minus 5. Okay, well, do the same. Well, let's see. We move 5 to the left side and y to the right side. So we'll get 5 equal to 3x minus y. 3x minus y equal to 5. So this is the same thing. It's just have different form. This is a point slope form. This is a general form. All right? So this is a second way. We don't directly look for the slopes. We just exchange coefficient and change one sign to be the opposite. Okay? Exchange or switch coefficient of x and y. Change only one sign to be the opposite sign. Let me do one more example. On page 179, problem 68. So the question is perpendicular to the line x minus 2y equal to -5 containing the point 0,4. Okay, so I'm going to use pencil first and then I will write it down. So first, this is the equation of the one line. How do I get the other line? X and y. Check here, y has coefficient -2, so you put a -2 as a coefficient of x. X has coefficient 1, so it's a 1. And this is 1. And then you're going to change, 1 has a positive sign. 1 has a positive. There's no sign means positive. And then you're going to change one sign to be the opposite. You can change this one, you can also change this one. For me, I'm going to change the negative sign to be positive. Okay, so I will put 2x plus y equal to D. And then you let x be 0, y be 4. X is 0, 2 times 0 is 0. Y is 4, just get 4 equal to D. So D is 4, the equation is 2x plus y equal to 4. This last step is used to determine this value D, because we just artificially put a D there. We don't know the value of D when we write down the equation. We have to use this condition to determine the value of D. The D does not depend on the point. Right? For this point, for that point, once you pass through the point, you will uniquely determine this D. Okay? So be careful here. Of course, you can change this minus to be plus, or you can change this plus to be minus. Either way, you will always get the same equation. All right, so this is the section, the long section 2.3, lines. In this section, we have 10 parts. we have 10 parts. It's a very long and complex section. It contains a lot of formula, especially for the perpendicular and the parallel lines. Do the corresponding exercise on page 179 from problem 45 to problem 70. They are all types of questions, all kinds of questions. Try to do all of them, understand the concept, and try to figure out the right answer. It's very important. This part is very, very, very important. Okay, so this finished the section 2.3. Now let's move to the section 2.4. Section 2.4 is the study of circles. Study of circles. Okay. What is a circle? First of all, of course, we all know what a circle looks like. Let's see the concrete definition. What is a circle? A circle is a set of points in the xy plane. What we normally call the plane xy plane, that are fixed distance r from a fixed point. This fixed point has coordinate hk. This distance r is called the radius. And this point hk is called the center. All right, it's called the center. So that's a definition. So you have a point in the xy plane has xy coordinate hk, and you get a distance, fixed distance r. Just get all possible point with the fixed distance from this point hk. Basically, based on your experience, you're going to rotate it. Okay, excellent. After you rotate it, you will get a circle. You'll get a circle. Okay, now let's see what is the equation of a circle. Equation of a circle. Assume you have a random point on a circle. On a circle, it has coordinate x and y. What is the condition about x and y? The distance is r. So the distance between hk, this point, and x, y should be equal to r. The point hk and the point xy should be equal to r. We know the distance formula. The distance is square root of x minus h quantity squared plus y minus k quantity squared is equal to r. Right? Of course, we don't want the square root, because square root, for most of the numbers, we don't know how to compute. So we are going to square two sides. We square two sides. We will get x minus h squared plus y minus k squared is equal to r squared. We square two sides. This part square, you cancel square root. The right side square, you just get r squared. So this is called the standard equation, a standard form of an equation. Standard form of an equation of a circle with radius r and the center point hk is just this, x minus h squared plus y minus k squared is equal to r squared. All right, so that's the standard form. Standard form, you see here, all the signs, symbols are fixed. So in the standard form, you must have minus minus, and this part of course is plus, and you must have r squared in order to get the corresponding r and the corresponding h and the k. All right, so for example, if we have x minus 1 squared plus y minus 2 squared is equal to, for example, whatever, 3 squared, then we know the center is, okay, center is a point, it has xy coordinates. You get 1, 2, and the radius is 3 because it's r squared, 3 squared. All right, but if we have this one, x plus 1, y plus 2 squared is equal to 9, then you have to realize this is plus a plus, so the center is not 1 and 2. So you have to write it as x minus negative 1 squared, minus negative 1 is plus 1, y minus negative 2 squared is equal to 3 squared. So the center is negative 1 and negative 2, and the radius is 3. Be careful, the radius is 3, is not 9. In the formula, it's r squared on the right hand side. Okay, r squared on the right hand side. Just be careful about this. Standard form has minus sign, so you have to write it literally as a minus sign in order to determine the xy coordinates of a center. All right? Okay, so if we have the center, if the center of a circle is the origin. Why we mention origins especially? Because origin has coordinate 0, 0. Then the equation of the circle is x minus 0 squared is x squared, y minus 0 squared is y squared, equal to r squared. Right? It's just looks simple. Looks simple because the center is simple. hk, you don't see it, they become 0. All right? And if r is 1, you have radius 1, the center is 0, 0. The center is origin. This circle is called the unit circle. Its equation is x squared. You see, the center is 0, 0, so you have to follow this. R is 1. 1 squared is 1, so it's x squared plus y squared equal to 1. This is the equation of a unit circle. Equation of a unit circle. Or it's just a name. Okay, so let's see the example. Write the standard form of the equation of the circle with radius 5 and center negative 3 and 6. Okay, write the standard equation. Well, let's just follow this. It's x minus x coordinates, x minus x coordinate, parenthesis squared, plus y minus y coordinate, parenthesis squared, is equal to 5 squared. If you don't want to do any any step further, just leave it like this. It's good enough for the final answer. If you want to write one more step, this is already good enough. If you want to simplify it a little bit, this is a way. Minus minus is plus, so you get x plus 3 squared plus y minus 6. It's just y minus 6. You cannot simplify it. 5 squared, 25. So this is also good for the final answer. Also good for the, okay? All right, so that's a standard form of the equation of a circle. Second part, graph a circle. How do we graph a circle? Well, let's see the example. Graph the equation. X plus 3 squared plus y minus 2 squared is equal to 16. First of all, when you read this equation, you should notice, well, the graph is a circle. And also you should notice that the center is, here it's x plus 3. You should imagine it as x minus negative 3. So the center has x coordinate negative 3, y minus 2, y coordinate 2. The radius is, see, 16. 16 is a 4 squared. The radius is 4. Be careful about it. The radius is not 16. The radius is not 16. It's a 4 squared. Okay, so now let's see how do we sketch it and what is the requirement. Negative 3, 2. Let's label. 1, 2, 3, 4, 5, 6, 7. Okay. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, negative 1, negative 2. Where is the center? The center is negative 3 and 2. Negative 3 and 2 is here. Okay, so again, center is one of the ingredients of the circle, but the center is not on the circle. Center is not on the circle. Center is not part of the circle. It's one ingredient of the circle. Okay? Okay, so when you have the center, you're going to go up 4 units. Why we say 4 units? 4 units, because the radius is 4, so you go strictly up. 1, 2, 3, 4. You see, this is 2. You go up 4 units, it's a 6. This point is on the circle. And you go down 4 units. 2, you go down. 1, 2, 3, 4. It's negative 2. So the top point, the bottom point are on the circle. And you go right 4 units. 1, 2, 3, 4. This point is on the circle. You go left 4 units. 4 units. We use 4 because it's radius. 1, 2, 3, 4. 4 units. Okay? Top, bottom, left, right. And then you use arc to connect them. Or just try your best to connect them. Okay, this is a graph of circle, and that's it. That's all the requirement. In this circle part, in the graph of circle, I only care if you label the center. I only care if you label the top, bottom, left, right, 4 points. Except that, try your best to draw the arc to connect those 4 points. Make it like a circle. Okay, so this is the graph. Okay, so when you have the graph, you see their intersection. 1, 2, 3, 4. There are 4 intersection points. let's try to find the intercepts of a circle. Intercepts of a circle. So for the circle x plus 3 squared and plus y minus 2 squared is equal to 16, the same circle. Find the intercepts, the xy intercept. Find xy intercept. Okay, not too difficult. For x-intercept, y is 0, right? X-intercept y is 0, so you let y be 0. So 0 minus 2 is negative 2, negative squared is 4. So you get x plus 3 squared and plus 4 is equal to 16, right? 0 minus 2 is negative 2, negative 2 squared is 4, so that's why I get 4. And then you get x plus 3 squared is 12. You take square root, you will have past 2 square root, positive and negative. So you get x plus 3 is square root of 12. Or, be careful, I always write this connection word. Or it is a negative square root of 12. Whenever you take square root without any other requirement, you always have 2 square root. And then you move 3 to the right side, you get x is negative 3 plus square root of 12, or x is negative 3 minus square root of 12. So these two are x-intercept. For the y-intercept, you let x be 0. Y-intercept x is 0. X is 0. X 0 plus 3 is 3. 3 squared is 9. So you got a 9 plus y minus 2 squared is equal to 16. So y minus 2 squared is equal to 7. You cancel 9 from two sides, you get a 7. And again, you're going to take square root of two sides. You will get y minus 2 is a positive square root of 7, or y minus 2 is negative square root of 7. Again, two square roots. And then you move 2 to the right side, you get y equal to 2 plus square root of 7, or y is equal to 2 minus square root of 7. So you have 2 y-intercept. So you see here, this is 2 plus square root of 7. This is 2 minus square root of 7. This is a negative 3 plus square root of 12. This is negative 3 minus square root of 12. So you have exactly 4 intercept. You have 2 x-intercept, 2 y-intercept. Right? Excellent. Next part. Let's see what we have. Remember, what is the standard form of a circle? This is a standard form of a circle. We know that x minus h, this is perfect square, x minus h squared. It is x squared minus 2hx and plus h squared, right? And y minus k quantity squared is y squared minus 2ky plus k squared. And if I move r squared to the left side, it's minus r squared equal to 0, right? So I'm going to rewrite it. I select x squared and plus y squared h minus 2hx y minus 2ky, and then I put h squared k squared r squared plus h squared k squared r squared. Why I put them together? They are all numbers. This is a square term, linear term, constant numbers. And this is so-called the general form. Okay? So the definition, general form. 1, its graph is a circle. When its graph is a circle, the equation The equation, what equation? X squared, y squared. Then this one we call it A, AX. This one we call it B, BY. And this whole thing we call it C, plus C equal to 0. This equation is called the general form of the equation of a circle. There's several there are several reasons behind this definition why we call it the general form, but so far we don't have enough material to discuss, so we will not present those reasons, but we just expand it and write it as a real polynomials, and we collect square term, we collect xy term, and we put constant term together, and this sequence is called a general form. Okay, so be careful. The standard form, you can directly read the center, the radius, but the general form normally is not so straightforward when you have the center and the radius. It has its meaning to exist, but it's not that straightforward so far. Okay, now let's see the example, see how we do the problem with general form. So graph the equation. Graph the equation x squared plus y squared plus 4x minus 6y and plus 12 is equal to 0. Okay, we're trying to graph it. Well, you see, this is a general form. We want to know if it really represents a circle or not. This process is a complete square process. Okay, so first I copy it. And then let's check what is A. A should be negative 2h. At least A is a 2 times h. Right? So here's a 4. You get a 2 times 2. 4 is 2 times 2. Why I like this number 2? The first number 2. The first number 2 comes from the formula. You see, here you have 2. So that's why I want to factor out a number 2. And then you have h. Then you need h squared. So I put 2 squared. This 2 is related to this 2. I got 2 squared. Okay, y squared. And minus 6y. Again, you have 2. So it's minus 2 times 3y. 2 times 3 is 6. It's a complete square. And the 3, I have 3. You have k, and you need k squared. 3 squared. Okay? And then I'm going to put equal sign. I first move this 12 to the right side. I get a negative 12. This is a movement. Okay, remember, this is a movement. I just move it to the right side. I don't change anything else. And now let's check. I add this 2 squared out of nowhere. So I'm going to add it on the right-hand side. This is left-hand side. This is right-hand side to balance it. I add 3 squared on the left-hand side. I will add it on the right-hand side. See it? So I move the constant term to the right side. Here, to complete square, I add 2 square. So I add the right side 2 square. Complete square, I add 3 squared. I add the right side 3 square. And this 2 and 3 come from the complete square process. And then the first 3 term becomes x plus 2 quantity squared. And last 3 term becomes y minus 3 quantity squared. And this is minus 12 plus 4 and plus 9. 4 plus 9 is 13. Is equal to 1. It's equal to 1, right? So 1 is 1 squared. 1 is 1 squared. So we know the center is what? Here. Check here. It's x plus 2. X plus 2 should understand it as a x minus negative 2. So the center is negative 2, y minus 3, so negative 2, 3. The radius is 1. 1 does not directly come from this 1. It comes from 1 squared is equal to 1 is from here. All right? Okay, now let's try to graph. The main problem is to graph it. So we have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 1, negative 2, negative 3, 1, 2, 3, 4. The center is negative 2, 3, negative 2, 3 is here. Radius is 1. You go top 1 unit, right 1 unit, left 1 unit, bottom 1 unit. And then you connect those 4 points with arcs. So you get a circle. That's it. That's it. Okay? So the graphing of a general form of a circle is like this. So I'm going to give you one more example. I'm going to give you one more example about this. And in this part, what did we do? We move this constant number to the right side, and then we complete the square. Okay, we move this number to the right side and complete square. Now let's check how do we do it. We are going to do one more exercise. On page 186, we have problem 32. 2x squared plus 2y squared and plus 8x and plus 7 is equal to 0. Okay, this is even more complex than the first one. Be careful. The general form x squared y squared has no coefficient. Here you have 2, 2. You divide, first you divide this equation by 2. Okay, so you must have x squared y squared separate without additional coefficient. And second, I'm going to move this constant number to the right side. And also I collect x with x, y with y. Okay, and then remember that here you have a linear form, linear term for x. For we need 2 times 2. And this 2, we need square, 2 square. It's complete square. Y does not have y term, so you don't do anything. Here is the 2 square, so you add a 2 square on the right-hand side. Okay, and then first the third term is just x plus 2, quantity square. Y square is just y square. If you have x term, you complete the square. If you do not have y term, you don't do complete square, just leave y square there. It's already done. And 2 square is a 4. Negative 7 over 2 plus 4 is 1/2. Okay, so what is the center? The center, now let me write it here. The center is negative 2. It has to be negative 2, x minus negative 2. Be careful. Negative 2, what is y? Y called 0. You don't subtract anything, it's y minus 0. The radius is, you need to find something squared equal to 1/2. Which number its square is 1/2? Square root of 1/2 has a square 1/2. If it is not a complete square, a perfect square, you just put the square root, positive square root, and that's it. This is a center and a radius. Okay, so do the recommended exercise. If you have a question, let me know and we can discuss it. Okay, thank you very much. We'll finish this video.